Welcome to Painless School, and today's class gonna be very interesting. And we have a question here, and it says a 250-meter long train passes a person in 10 seconds. The person was running at 5 km per hour in the opposite direction of the train. What is the speed of the train in kilometer per hour? So here they says kilometer per hour, the speed, but we have a 250-meter, so we need to convert it in kilometer. So we need to divide 250 by 1000, and then we'll get the kilometer, and it's 0.25 kilometer. Okay, and 10 seconds, we need to convert it in hour, so I need to divide 10 seconds by 3600 seconds, so we have 1 by 360. Okay, so this is the scenario here, and let's move forward. Okay, first of all, we need to know a common equation related to speed, distance, velocity, whatever it is. We have a equation, and it's d equal v into t, where d is a distance, v is a velocity, and t is a time. Okay, so now come to the point here. This says this train is moving into this direction, and let's say the man is moving into this direction, and we have a common distance, and this is a 250-meter. That means it's the distance is 0.25 kilometer, and they both covered the distance in 10 seconds. 10 seconds, that means if the train is in here, they meet here, the man is in here, and the train starts moving this direction, and the man starts moving that direction, and both take 10 seconds each, and they cover the 0.25 kilometer distance. But what happens if we take the total direction, the distance is 0.25 kilometer. It's 0.25 kilometer. We have 10 seconds for each. Let's say it's for the train. We have the 10 seconds for the train, and we just assume that the man is standing here. The man is standing here just right. He has no velocity. We added the man's velocity to the train's velocity. Say the train's velocity is v1 and the man's velocity is v2. So we added the total velocity, and we have the total distance, and we have time too. So if we want to cover the total distance with this velocity and with this time, we can figure out the train's velocity, right? So here is a scenario. If the train is moving right here and the person is moving right here, and they have same time, 10 seconds, he has v1 velocity, he has v2 velocity, and the total distance is d. So what happens here? This distance is, say we say d1 is equal v1 into 10, and this distance, let's say it's d2, so d2 is equal v2 into 10. Let's add d1 plus d2 is equal 10 v1 plus 10 v2, and here it's a common 10. We take common 10, v1 plus v2. Look here what happens. We added the total velocity. We have the same time and we have the same distance, and that is 250 meter, means 2.25 kilometer here. Okay, so now it makes sense. So we assumed the train is moving here, and this man has no velocity because we added the total velocity, his velocity and the train's velocity is v1 plus v2, and the total distance is 0.25. So make an equation, it's 0.25 kilometer. We have, but we don't know the train's velocity is v1, and we know the person's velocity, it's 5, and we have time, it's 1 by, we solved it here, uh, 1 by 360. So now here 1 by 360, and so multiply 360 with 0.25. It's it's a 0.25 into 360, 0.25 into 360 here, and v1 plus 5 on this side, v1 plus 5, and this is 90, and we on v1 plus 5 here, subtract 5 from 90, and it's 85 kilometer per hour. So the train's velocity is 85 kilometer per hour. Thank you. Hope it's clear.